In this lesson, we are adding and subtracting with scientific notation. Similar to adding or subtracting with decimals or adding and subtracting with fractions, we need to consider a couple of things that need to be the same in order for us to be able to actually successfully do this correctly. So I'm going to start off with an example. 2 6/10 times 10 to the power of 6 plus 4 2/10 times 10 to the power of 6. You'll notice that our decimals are both to the tenths place, and our base 10 have the same exponent of 6. Okay. Similar to adding and subtracting decimals, we do need to line up our decimals. But in order to have our decimal places be accurate, this exponent has to be the same. So this first example, we have an exponent of 6 for both. So all I'm going to do is simply add up my decimals, 2 6/10 plus 4 2/10. And similar to any decimal places that we're adding, or similar to fractions where we have to have the common denominator that stays the same when we're done, our final answer is going to have 10 to the power of 6 because that is my base. Okay, so 6 plus 2 is 8. 2 plus 4 is 6. I'm going to drop my decimal down, and my final answer is 6.8 times 10 to the power of 6. Another example where we have the same exponent, 7.2 times 10 to the power of negative 7 minus, this time, 4.5 times 10 to the power of negative 7 as well. So the first thing I'm checking for, like I already mentioned, I'm checking to make sure I have that same exponent so that I can successfully combine these. So I'm going to take 7.2 minus 4.5. My base 10 is going to have an exponent of negative 7 because they match. And 2 minus 5 I have to borrow here, so I end up with 12 minus 5 is 7. And 6 minus 4 is 2. I dropped my decimal, and this is my final answer. Now what happens if I have two scientific notation numbers that don't have the same power? So what I'm going to do, let's take a look at the example. 9.3 times 10 to the power of 4 minus 7 times 10 to the power of 3. Now what we have to do is one of three things. I will let you know which one I recommend depending on the situation. But the first option is to turn these numbers into standard form. When the number for the exponent is smaller, like this 4 and this 3, that is a valid option. When you're dealing with numbers, say 24 is the exponent, or 37 is the power with the base 10. Those are not going to be so realistically switched to these standard forms. So, standard form is one option, and to change this number to standard form, 9.3, 10 to the power of 4, so 1, 2, 3, 4 is how I'm going to move my decimal, so I end up with 93,000. And this 7 times 10 to the power of 3 means I'm going to move the decimal 3 times, and I end up with 7,000. So I'm going to line up my place value. 0, 0, 0. 93 minus 7 is going to give us 86, I believe. 13, 8, yep. Okay. So that is one option. So we know that our final answer should be 86,000, or its equivalent scientific notation, which is 8.6 times 10 to the power of 1, 2, 3, 4, right? So I'm going to cover that up for a minute. Another option is to change the exponent of one of these scientific notations. It is strongly recommended to make the exponent the larger exponent, so changing this 3 into the 4, because when you do your subtraction, you are more likely to end up with a number that is larger than 1 to 10 in your decimal spot. So we want to make sure that we don't have to move things around for scientific notation again later. I will show you both ways though, so if you do it the opposite way, you know what to do and how to fix it. Okay? So what I do here is I'm going to rewrite this out so I can have it ready to go. So I have 7 times 10 to the power of 3. In the previous lesson, I mentioned how if we move the decimal in one direction, we move the exponent in the other direction. Well, I know I want to move the exponent up because I want to make this 3 into a 4, right? 10 to the power of 4. So I'm going to move this up one time, which means I have to make this number smaller by moving the decimal one time. So the decimal is always at the end of a whole number. I'm going to move it one time to the left. So I'm going to line up my decimal place, 0.7 times 10 to the power of 4. So when I move the exponent up, like a seesaw, the decimal is going to get smaller by one time. Okay? Now I can simply subtract. I'm going to have 10 to the power of 4 as my base. And 9.3, I'm going to borrow my 8 and 13, 6 and 8, drop my decimal, and it does end up being the same thing as we have here. Okay? The last option, and this is not as recommended, especially with subtraction. With addition, it could be fine, but with subtraction, not necessarily recommended, is to take the larger exponent and change it into the smaller exponent. So I'm going to make this number into a 3. So if I'm trying to make this become a 3, I'm going to move that down, which means I'm going to move the decimal to the right to make this a little bit larger. Okay? This exponent gets smaller, which means the decimal is going to move to make this number larger. Okay, so I end up with 93 times 10 to the power of 3 minus 7 times 10 to the power of 3. And I get 86 times 10 to the power of 3. Now the reason this isn't as practical is because, if you notice, this number here is not between 1 and 10. So it's not in scientific notation answer form yet. So what I have to do is I'm going to make this 8.6. And I moved that decimal to make the number smaller, so I have to move this to make that number larger, the exponent larger. Letty is fine, for the record, if you hear her yelling in the background. She's okay. And this would be my final answer as I figured out before. One last quick example. We're going to add when we have different exponents, but this time the exponents are negative, okay? All right, so we have -5 and we have -7. We are going to recommend moving to our larger exponent. This is our smaller one because remember, when it's negative, 7 is smaller than 5. So I'm going to move this 2 times to make it larger. So this is going to move 2 times to the left to make it smaller, okay? So I have 0.057 times 10 to the power of -5. I'm adding that to 3 and 23/100ths. I'm going to place a 0 as a placeholder just so I can make sure I don't make any silly mistakes when I'm adding. I have 10 to the -5 because those are the same. 7 plus 0 is 7. 5 plus 3 is 8. 0 plus 2 is 2. And 3 plus 0 is 3. If I had moved this to a power of -7 over here, then I would have ended up with a number smaller than 1, which means that I would have had to adjust again, okay? But this way I didn't have to adjust. I could have also made these numbers into standard form, but if you take a look here, so we have 5, 7, right? I have to move that 7 times to the left. 1, 2, 3, 4, 5. I don't even have room on the screen here. So this number would be really, really tiny. And this number would also be pretty tiny, so just not very practical to use standard form when I can simply adjust my exponent. Happy practicing!